Dear students, now we are going to discuss about divergence theorem and its proof applications. Consider a region. Here the A vector is the outward flux through this surface around this volume. Divergence theorem states that the total outward flux of a vector field through any closed surface is equal to the volume integral of the divergence of that vector. So here volume integral of the divergence of that vector. Divergence means what? It is the measure of quantity of flux emanating from the region. So here it is a volume. From that volume, how much flux is getting generated towards the surface. That is the concept. So we can mention like this. The surface integral of this normal components of A vector is equal to the volume integral of divergence of that vector. Both are equal. We can consider surface. The same can be written in terms of volume by using a divergence concept. So here divergence theorem relates surface integral and volume integral. Next we are going to prove the concept. How can we obtain the surface integral out of this volume integral? Okay, so for that we have to consider a vector that is equal to Ax unit vector Ax plus Ay unit vector Ay plus Az unit vector Az. The divergence of any vector is, this is the formula as we know, right? So del dot A vector is equal to dou Ax by dou x plus dou Ay by dou y plus dou Az by dou Z. So next we are going to take the volume integral on both sides. So take the volume integral on both sides. Okay, so here we can mention it is dv. So volume integral of del dot A vector into dv is equal to dv is nothing but volume integral is mentioned as dx, dy, dz. Here we are considering only the Cartesian coordinate system x, y, z. Okay. So dv is nothing but what? Dx, dy, dz. It represents these three coordinates. So in this side, right hand side, we can write volume integral of dou ax by dou x plus dou ay by dou y plus dou az by az into dx, dy, dz. So this volume as well as this term is common for all these three components. X component, Y component, Z component. So we can write down this expression like this. So volume integral of dou Ax by dou x into dx, dy, dz plus volume integral of dou Ay by dou y dx, dy, dz plus volume integral of dou is Az divided by dou z dx, dy, dz. We can consider this as the first equation. So next we are going to take this term alone and solve this term. Likewise we can obtain the solution for this too. And then substitute those values in this equation to get this volume integral of this divergence of A vector. Okay. So first we have to take the volume integral of dou Ax by dou x dx, dy, dz, that term. So in this one, what I am going to do? I am going to take this part alone first. So surface integral, that is double integral, and I am going to take this part, as we can cancel this to dx, and integral of dou Ax is nothing but Ax, correct? Integral of dou t is nothing but d, right? So same thing. So integral of dou Ax is nothing but Ax into dy dz. So here this dy and dz, it is nothing but the components of x surface. So here we can rewrite this term as double integral of Ax. This dy and dz is nothing but ds of x. So dy dz is nothing but what? The components of x surface. Okay, so we can rewrite like this. So consider this as the second equation. So similarly, we can get volume integral of dou ay by dou y dx, dy, dz is equal to, again we can take this dy here. Okay, move this dx this side. So this will become, this dy cancel. So we will get integral of dou ay. So we will get only ay. The remaining term dx dz is called as the y components of the surface area. Okay, this dx and dz are the components of y surface. Okay, so we can consider that as the third equation. Likewise, we can get volume integral of dou az by dou z dx dy dz becomes the same way. We can obtain surface integral of az dsz. Okay, so we can get all these three things. Now we are going to substitute the second, third and fourth expression in our first equation. So what is our first equation? So that is volume integral of del dot a dv is equal to volume integral okay, of each component. So that can be replaced like this. So x component can be written like this, y component and z component. So now we can write the double integral is common for all. We can take it outside. Ax dsx, ay dsy and az dsz. Okay, so we know that this ax, ay, az is coming under a vector. Okay, so these three surface areas are grouped together to make the closed surface for that region. So we can simply mention that as the ds. So the volume integral of divergence of that vector field is equal to the surface integral of the normal component of the a vector. Okay, so that is proved by this way. So next, applications of divergence theorem. Divergence theorem applies to time varying and static field. Okay, so next it is mainly used to convert the volume integral of a vector into a closed surface integral. So it relates both volume integral and surface integral. So we can easily convert from volume to surface or surface to volume. It is widely, this concept, okay, this concept is widely used in the field of engineering, in electrostatics and fluid dynamics. Okay, so especially to derive any mathematical relationship, we can use this divergence theorem. We are widely using this concept to obtain the Maxwell's equations in electromagnetic field.